Okay, this first video here, we're going to be covering the nerve block modeling repository. Specifically, we're going to look at the GitHub page and the various folder structures set up within this repository, and probably take a little dig around the documentation left. So, let's dive right in. So the nerve block repository, this is essentially, it's a collection of scripts in various languages, and we're going to utilize the Neuron simulation environment, and we're going to be doing high frequency alternating current, and there's also additional code for direct current to block action potentials. So we're using electrical stimulation to block action potentials. And with that, let's get into how we can use this code and where everything is. So if you couldn't tell by the name of the folder, the current simulation folder is kind of where all the code for the current simulation environment is. So this is the code you're going to edit. We can see within here we have things that will be controlling the electrode parameters and other models within it. And so this is the main code you're going to be working with. Within it we have the models folder. So within our current simulation folder we have the models, and these are the .mod files that we load up to build the axon we're going to be looking at. Specifically, these are going to be used to build the MRG model, the McIntyre-Richardson-Grow model, and you can check out their 2002 paper for exactly what all that entails. So that's the current simulation folder. This is where you're going to be doing the majority of your work. This is what you'll load up. This includes all the GUIs that'll be loaded when you start up Neuron and get in there. So once we get done with that, now we can move to the data folder. The data folder, I don't recommend just uploading all your data. That'll take up a lot of space in here. There's kind of specific data sets and example ones for everybody to kind of look at. Within here, obviously we're using the current simulation folder to get these, get this data. This also includes a sample setup to kind of standardize what parameters you make sure you keep track of in every simulation, which can be really useful when going back and looking at data. There's also a warning here. Not every model is going to be perfect. We just kind of hope that the code we write is a perfect representation of the model we described, and sometimes it's not. And so when bugs are found in the code, we need to make sure that we acknowledge them and bring them to everybody's attention so that all data can be taken with the grain of salt it needs to be taken with. And we'll look further at what this issues tracking page is as this video goes. So that is the data folder. You probably don't need to mess with it too much. It's kind of just some sample stuff to kind of get you going if you need to. The deprecated code folder is exactly what it sounds like. It's old code that's either been replaced or never used, or some other reason has caused it to be irrelevant for the majority of work. And instead of just deleting it, we save it to make sure that we give credit to those who have contributed to the project, whether it's directly or indirectly. So that is this. You shouldn't ever really need to go here unless you're looking for a specific thing that you know happens to be here, or you're looking at who has previously contributed. The Python scripts, this is where we can get into some more advanced topics later on, but Python is really great for if you're doing large amounts of work and you either need to may set up like a bunch of Neuron trials to run back to back. Python's really great at automating that. Python's also useful, I found, for multi-threading a lot of workloads. So if you have maybe 100 block threshold tests you have to run, then sometimes it's useful to spread that across multiple cores on your CPU. But that'll be described more in later videos. So Python, that's kind of the point for that. You shouldn't really need to use it too much. And it also relies on the current simulation environment. R code is kind of used as a starting platform for data analysis. Kind of gives you some useful functions to kind of hit the ground running in R. if you want to use that for data analysis. I particularly used it for data visualization. I think R is really great for that. And so hopefully these useful functions will get you over the hurdle of loading the data into R, and you can hit the ground running by just start graphing the data as fast as possible. So if you haven't used R before, this might be kind of confusing to you. But if you used R before, hopefully the useful functions will be useful. The other folder we have here, the last one, is our wiki folder. The wiki folder is really just a collection of images sorted into various folders. And the main reason for that, if we look at one of these images, this one actually taken from another paper, so we gotta make sure we reference that. When we look at the Wikipedia page, we'll hopefully see that we can link images if they have a static web page, and so when we upload them to a repository, they're going to have a static web page that we can link to. So that's the wiki. It's really just for storing images for documentation. Below that, as we might have seen before, we have a README file. Every folder in here had a README file that kind of loaded up, and additionally we have documentation on what all the folders are for. If you'll notice the wiki page, it's highly recommended that you check out the wiki by either clicking on that link at the bottom or clicking on the wiki tab at the top. The home page gives you some links for setup. It also gives some links for the Neuron documentation, and on the side here we can see a couple of extra pages that are usually devoted to specific topics, whether that's made an example of phase plane analysis where we have a sample GIF that's been created, or if you want to look at the frequency dependent membrane capacitance, there's a bit of a documentation on why it was done, how it was done, and testing to show an accurate representation of what was described. So those are the two main things. The code and the documentation kind of go hand in hand, as they should. Additionally, on the code side, when you're kind of ready to get going with this, there's you can either download the code using standard Git tools or the GitHub desktop application, or you can go to the releases if you're not planning to do any changes to the code, and download a zip file of all the source code to get yourself up and running. Additionally, if you noticed when I went to code and I clicked on this releases button over here, we can see there's actually a lot of releases. The initial release, and then as updates were done, I tried to give a new release for when major updates happened. So always recommend using the most recent release of the code to avoid any unnecessary bugs. So let's say you're using this for a while and you have an idea for a new feature, or maybe you found a bug in the code, something doesn't work. There's the issues page over here, and within that you can submit a new issue, and there's already templates set up for whether it's a bug report, a documentation request, a feature request, or maybe it's just a question you had about the repository and how to use it. When you submit one of these, you can get started and fill out the little form. That'll automatically update whoever owns the repository, and they can immediately see what is happening, and it kind of keeps track of all the ideas of the repository in one location. And if you notice, we can click on the open ones and you can see a lot of them have already been worked on. So within that, if you're a bit more experienced with Git, you might know about merging and pull requests and branches and all that. In GitHub, you can look directly at what pull requests are open and handle those accordingly. If you're not experienced with Git, I recommend you do, but it's not a necessity for this. The other tabs here, we went over the wiki tab. The actions and security are pretty irrelevant because GitHub does not recognize that we're using Neuron, and so it doesn't recognize hawk code and stuff like that. So it can't really help us with security, and there really aren't any builds that we're trying to ensure that we're not breaking. So the actions are also not that terribly useful. The Insights tab can be useful if you want to look at the network and see all the changes that have been done. So if you go to the Insight tab and network, every single dot is a different update, and all of them are dated and signed. So if for some reason you needed to go back to a very specific version, you could. And that's one of the great things about Git, is the excellent version tracking. So kind of as a recap, in this video we covered the folder structure of this repository, a bit of the documentation so that you know where to go when you need to find it. We cover the wiki page as well, and issue tracking for any additional problems you occur. And don't forget the releases link over here to be able to get source code if you're not using Git tools. So hopefully that was useful. The documentation should have all this information, but if not, you can always go back and rewatch the video. So we'll see you in the next one.